Welcome to our next piece of rivers. So there's different stream types, and I'll start with intermittent streams because this is what we have in Southern California. Because we've got a Mediterranean climate, we have a distinct wet season and a dry season. And so obviously in the dry season, there's nothing to supply water to our rivers. So often we see that we have what we would consider a dry stream bed. It's just that it's not carrying anything now. We still get some subsurface flow that will flow into the streams, and so for right now, there actually is water flowing in some of the local creeks that we have, but not a lot. And that's mostly because locally we just had some recent rains, but it's not uncommon to see all of our streams be dry during the summer. That's an intermittent stream. So your monsoonal climates, the tropical savanna, which you're seeing in the photo, those have dry seasons where we can see no water in the stream. Now, intermittent implies that it's consistent. You have a wet season and a dry season. When we talk about deserts, we'll talk about what's referred to as ephemeral streams. Those are inconsistent, where you can have it wet during, basically any time during the year, but it has significant dry periods as well. This is a wet season and a dry season. Now, how low can a stream cut down? How much can it remove? How much can it transport? Because if it keeps removing material from the bottom of the stream bed, in theory, you think, well, it's just going to keep eating downward and downward and downward as it transports the material away. Well, there's got to be some hypothetical lowest point it can devour. Because if the Colorado River, as much erosion that is taking place, as it keeps cutting downward and downward through the Grand Canyon, it's not going to cut down to below sea level, because then the river would have to flow uphill to get into the Gulf of Mexico, the Gulf of California. And that's just not going to happen. And so as streams approach their lowest thing that they could erode down to, what we typically, which is referred to as their base level, what typically happens is the discharge decreases because the water isn't flowing out of the stream as fast, and so it's unable to transport as much stuff because velocity drops off. And so as it slows, we start to see it depositing material or not being able to transport as much, so if it can't cut downward any longer. Now, you may have local base levels like a lake where the stream will cut down to that, but not below the level of the lake. So dams can often affect the stream discharge, and we'll see that when we look at some of the rivers some of the lakes along the Colorado River. So the ultimate base level for any stream is usually the sea level, is ocean. With the farther you are away from base level, your typical stream has a high discharge rate because it's got a high velocity. It's really trying to cut down to base level. As it approaches base level, velocity drops off so significantly, its discharge level is really, really low when it comes to being able to move the larger material. This is typical for most streams. The farther from the base level, the steeper the gradient, and the more discharge that takes place. You can even, if you drive out Ortega Highway here in Orange County, as you're coming up from San Juan Capistrano, you're down in the gentle gradient area. The river's just moving a little bit of sand and lots of clay. As you get up towards whatever that institute is along the way, you're starting to see a little bit, you're driving uphill a little bit, and then you're seeing in the stream bed some small gravel. And then once you get to the point where you're driving in the canyon itself and there's really not a floodplain, no flat area on either side, then it's moving the gravel and rocks, but it's also significantly steeper as you're climbing up and over Ortega Highway. So high gradient, what you're seeing is downward erosion. It's eating away at the bottom of the canyon, and it's eating away here, and so in doing so, it's creating this characteristic V shape for a canyon. So if you see a V-shaped canyon, it's trying to get to base level. So it's a high gradient, high velocity, lots of down cutting creates a V shape. The low gradient, look, even my voice slowed down. Instead of with its velocity decreasing so much, it tends to what's called meander, move back and forth across the valley floor, slowly widening it. Its velocity is low enough that it's typically only moving the suspended and the dissolved load in it. You're not seeing rocks and gravel in the bottom of this. It's just simply moving too slow. And it's slowly but surely, since it's not cutting down, it makes the valley wider and wider over time. And so we'll see these floodplains as the stream moves back and forth across it. We'll talk more about floodplains in a later. So Urubamba, so now we're on Machu Picchu. Aguas Calientes is just around the corner. We're up in the Andes, and so we're seeing this characteristic V shape that we would expect to find for a stream that's so far away from base level. We're in New York, we're almost to base level, nice floodplain, no big gradient. Now the Athabasca River, this empties out onto the plains of Canada, and so as it goes from the gradient of the Rockies in Canada, it hits the gentle gradient of the plains, and it goes from narrow valleys into these wider floodplains. Now, that process that happens with a stream being cutting down over time, it was thought that a stream would be cutting a V-shaped pattern, and so over time for any given landscape you would see it millions of years ago being these V-shaped canyons, and then today it would eventually make its way to this what's called old age pattern, where you've got it's approached its base level and it meanders side to side. Turns out it's a little more complex than this, but the terms stuck. And so when a stream was young, that's the high velocity, high discharge, high in the mountains, it has that V shape. As it matures, early maturity, you still have the V shape, but it's not quite as steep on the sides. And then as it's in its late maturity, it's getting closer. We still have some steep sides, but we're starting to see a floodplain until eventually when it's old age, like the Mississippi River is in Louisiana, it's reached these meandering and these really large floodplains. Turns out it's not that simple, but the term stuck. And so a youthful stream may be never reached this point just because of tectonic activities. So like the youthful streams in the Andes, those are still lifting up, and so they're going to be youthful for a long time until that other tectonic process starts. So I'll be using the terms youthful and old age, high discharge, high velocity, far from base level, and then the old age I'm referring to approaching and almost at base level. Now I mentioned the meandering pattern, the meandering pattern that takes place in the streams, and what we're seeing is the high gradient streams, it really doesn't meander as much because it's moving quickly and it's removing the stuff from the bottom. It doesn't have a lot of side to side action unless it starts to turn a corner or anything. But when it slows down, what we see is that side to side action becomes more noticeable, and the fastest part of the streams is no longer in the middle. It's anytime it goes around a curve, that motion kind of throws the faster part out to the edges. And so for high gradient streams, the fastest part tends to be in the middle. For a low gradient stream, it tends to move from side to side anytime it makes a curve. So that side to side motion is going to eat away every time it comes in contact with the edge of the stream channel. So it's slowly going to push out the edges over time, which is going to amplify those curves. So we see erosion on the outer edge of the curve. Wait, we have a low velocity on the inside of the curve. So if we have a low velocity, how can it transport stuff? It can't, so it deposits. So you literally are moving side to side across the valley, because on one side you're eating away material, on the other side you're depositing it. And so we would see this stream channel move this way, but we would also see this side move this direction as well. So that's where we get this lateral motion back and forth across the floodplain. Over time, every time it hits the sides of the floodplain, it eats away a little bit at that. For example, the Mississippi River is, oh my gosh, it's miles and miles across for the floodplain down in the lower portion of it. I don't remember the exact number, but it's something where it's actually difficult to see if you're in the middle where the actual edges of the floodplain are, because they're so far away. Now there's some weird things that can happen. That Urubamba River I was showing you earlier, that was going by Machu Picchu. This is, a few dozen miles away from it. But what happened, they had this weird local uplift. Remember, it's the Andes. There's tectonic processes going on. So it actually took a valley floor and tilted it a little bit so it didn't have as high a gradient. Well, that valley floor without a high gradient started cutting side to side in the Andes. And so this is one of the reasons that the Inca could feed large populations, is they were lucky to have large flat areas up in the mountains. That's not usually what happens. So in the floodplain, and there actually will be test questions on this to identify some of these features, and I'll go through how some of these form, but the keys are the fact that the stream meanders back and forth as it goes through, and we'll see some of the other things that happen as well. And also we'll talk about why there's these little raised areas on both sides of the stream in the floodplain. So those raised areas, those are referred to as the levees. Now the levees occur when it floods. So normally it's just in the stream channel in the bottom of the valley. Well, when it floods, instead of the water moving down the stream, it moves sideways. Well, when it moves sideways, the depth decreases, and it also, the volume of water decreases, and the velocity decreases. It's moving faster in the channel going down the river than it is going sideways away from the river. Well, if the velocity decreases, the depth decreases, what do you expect for the discharge to happen? Discharge decreases. So anything it was carrying, it just dumps. So as soon as it leaves the channel, it dumps a lot of sand and gravel. Well, those will build up over time. So eventually, your river in the non-flood stage could be higher, the bottom of the river could be higher than the floodplain itself. It's just simply in the low discharge events times of year, it fills up its river bottom, and then when it floods, it goes over the top and makes these larger and larger and larger. And so anytime, if you've been to the Midwest and been to one of these big streams, if you're in the floodplain, you actually can't see the stream. You've got to go up a hill to be able to see the stream because of the levees on both sides of it. Other cool things, one of us just because I like the name, and the other one just because they're interesting. A Yazoo, it's a river. It's actually named after the Yazoo River in the Mississippi River floodplain. So Yazoo is, you've got all of this drainage into the floodplain. Well, if I've got levees on both sides of the stream, how the heck is this water supposed to get through here and then flow uphill into the river? No. So the water will collect in the sides of the floodplain near the stream itself. Now, it may not create its own little stream. It may just create some marshy areas called back swamps. Or if there's enough flow, it may parallel the main stream. So you could have multiple streams in one floodplain. So here we've got the Yazoo flowing along the side of it, and then you've got these other areas next to the main channel that are kind of becoming marshy. Now these levees, remember, they're raised. And so if you get a high discharge event, and remember this is where the maximum velocity is on the outer edge, it may breach the levee and go over the top of it. And in doing so in a single point, this is going to be flowing downhill into the floodplain. Wait, if it's flowing downhill, it's picking up speed. So as it picks up speed, what's it going to do to the sand and sediments? It's going to start carrying them away. So it will eat into the levee. And notice that this is bank to bank here, but down here it's not bank to bank. You're actually seeing some wet sand, which means this water level has recently lowered. This stream is now changing its path and will now start a new path in the floodplain and abandon this old channel. So you'll see in areas that have floodplains, areas that used to have water in them, which are called meander scars, but don't anymore, and it's because that water has shifted its path in the floodplain. Give you an idea how big some of these floodplains are. The nice thing is it's nice agricultural land, but this is on the levee looking across the floodplain in the Midwest. Now, in your tropical monsoon climates, that flooding can be extreme. And so you'll see people who have adapted to living in the floodplain where you have areas that you just abandon for part of the year because they're going to be underwater. So you make them out of stone and then you just remove anything you don't want to get wet. And then you come back when the water level is dry. And here, or you'll have cities that build up right as close as they can to what the highest flood levels are. And so this is your kind of marginal areas for people who can't afford to be in the areas that aren't going to flood during the dry season or during the wet season. I love these photos because you can see the ancient pathways of the streams that used to be and where they are. This is a cutoff lake where the stream kind of changed its path. What's happening here, these are referred to as oxbow lakes. So we've got meander scars for where the paths used to be, but we also have these weird lakes kind of paralleling along the sides of the stream. And so we can see here where the stream used to take this path, and now it takes this path, and it leaves behind this cutoff lake, or oxbow lake. Now, floodplain of the Mississippi River, wide, flat, vast. This is the edge of it way the hell over here. and then the floodplain for the Tambopata, which is one of the tributaries to the Amazon River in Peru. Nice and flat. Had to climb up a really high tower just to get a picture of flatness. And that's Bolivia off in the distance. All right, when we come back, we'll move to river deposition and deltas. We've gone from erosion to deposition.